Hey guys, this is the beginning of the notes for chapter 10 and 11 that we started today. The first four slides that we're going to go over, there's nothing about those in your textbook, so this is just from the class lecture is the only place that you're going to get this information. So our unit's a little bit different. This unit, when we finish chapters 10 and 11, instead of taking a test, we're going to do some projects, and those projects are all going to be focused around constructive and destructive forces and how they change rock formations. So before Christmas, we finished up the rock cycle, and now we're going to get into a little bit more of the forces and how those cause changes. So everything that we're going to look at in this unit, we're going to talk about whether it is constructive, as in it's building new rock formations, or if it's destructive, in that it's going to reduce the amount of rock formations. So that's what we want to keep in mind. Are we building more rock formations? That can be continental or oceanic crust, or are we destroying continental or oceanic crust? Now, there's two new vocabulary words in this unit. The first one is uniformitarianism. Uniformitarianism is slow and steady change to the earth. The word uniformitarianism starts with the word uniform, and uniform means to be the same. These are a few examples: weathering, erosion, deposition, and lava flows. Those are a few examples of uniformitarianism. All of those are processes that slowly change the earth day in and day out, a little bit every single day. The opposite of uniformitarianism is a word called catastrophism. And catastrophism is geologic change that happens quickly. So we're not looking at a small change each day over the course of hundreds of days. We're looking at an instantaneous impact, like when you have a tsunami or an earthquake or a volcanic eruption, and the rock is changed very quickly. Both of these are important to change in rocks. Usually the earth is shaped by very slow processes, uniformitarianism, changing a little bit each individual day. However, occasionally we will have quick dramatic change, and usually those changes are much larger in scale. So your book starts out talking about how we know about the Earth's interior, because we've never been able to dig down that deep in the Earth's interior. And it talks about how using earthquake waves and rock formations themselves, actual rocks like we talked about in the last unit of the rock cycle, both of those give us clues to how we were able to come up with this model of the Earth. Hopefully you remember this model of the Earth from elementary school, where you talked about the four main layers of the Earth, and we're going to quickly review those. They are in your book, and if you have any questions, you can let me know, but hopefully you'll see that this is an elementary school review because you guys learned this in 4th grade. The Earth's inner core is a solid made up of mainly iron and nickel. It is the hottest part of Earth. It's where we have the most pressure of anywhere on Earth because all the rock layers are built upon it. It's a little bit complex in understanding why it's a solid, the inner core. And so I included a short little video here. Even scientists don't completely understand why it's not melting like the outer core is. So the outer core is a liquid. It's molten material. It's that magma inside the earth that we're talking about. And so it's a little confusing how we have this solid in here. So that's why I included that video for you. How we know this is a liquid, because we've never been able to dig or travel to the center of the earth, is by studying earthquake waves. So earthquake waves, like all waves, travel differently through solids, liquids, and gases. While you might not have much experience with an earthquake wave, you probably have some experience with sound waves. Sound waves travel very differently through solids, liquids, and gases, just like earthquake waves do. So if I'm talking to you and you're in another room and you're trying to listen through a wall, which is a solid, it's very difficult to hear as if you were in the same room with me with just that sound traveling through a gas. So solids and gases travel differently. If you were to go underwater in a pool and I were to try to tell you something under the pool, it would sound very different again, because the wave travels differently through a solid, a liquid, and a gas. Because earthquake waves that are traveling through the solid mantle, when they reach that liquid outer core, begin to travel differently, scientists were able to determine that the outer core is a liquid. The mantle is the largest layer of the earth. It's most of the earth. It's the main thing. And the mantle actually has parts. So in elementary school, you didn't probably learn about the parts of the mantle, and we're going to start talking about those today. The mantle is primarily a solid, but there are parts of it that move, and your book says similar to putty. That's like Play-Doh. They move kind of like a Play-Doh substance. And the outermost layer of the earth is the crust. The crust is the thinnest part. It is not just the continents, because if you were to dive down to the bottom of the ocean underneath all that water, you would find the ocean floor, which is a solid layer of rock as well. So it is both the rock that is under the ocean and the rock that makes up the land masses on Earth. So hopefully from elementary school, you guys remember this: the crust, the mantle, the outer core, and the inner core. If you have any questions or need more of a review on that, please let me know. This moves in a little bit more to kind of maybe some middle school terms that you may not have got into in elementary school. These two words that we're going to be discussing today are the lithosphere and the asthenosphere. The lithosphere is the very top part of the mantle and the Earth's crust together. This is what's broken into our tectonic or lithospheric plates that you guys read about. So let's look at this diagram. Here's some continental crust in the dark gray and the oceanic crust in the orange. We've got the ocean on top. There's a little beach where the ocean meets the land. We've got mountains and valleys. So this is the crust. Right underneath that, the very top part of the mantle kind of holds these two crusts together. All of these rock formations are on it. This very top part of the mantle with the crust is extremely rigid and hard, and that's what makes up our lithosphere. And this is what's going to be broken into those tectonic plates. Right below that is the asthenosphere. The asthenosphere, and the definition's down here, the asthenosphere is the Play-Doh consistency. It's still a solid. If you were to get some Play-Doh out of a jar, you would know that it was a solid, but it has movement to it. So we have this movable, and it's not flowing, it's not like a liquid, but it's movable, and as it begins to move within that more putty-like asthenosphere, that rigid lithosphere on top of it can begin to break and crack, and we're going to look at many of the formations that happen on Earth as a result of that. In your book, you had a similar picture to this. It was different, showing you major tectonic plates on Earth. I do want to point out to you that the tectonic plates are not oceans and they are not continents. So when you look at this map, you'll see that there's not a tectonic plate for the United States or even for all of North America, because this tectonic plate includes not only North America, but also a lot of the Atlantic Ocean. You're going to see that tectonic plates can be just ocean, like the Nazca Plate, and it's not a whole ocean, it's just a piece of it. Or it can be just a piece of land that's connected to other pieces of land. So we're going to get into tectonic plates and their boundaries and how they move more in our notes that are going to come on Friday of this week. So going back to the slideshow, I do have a link. So in the slideshow, on the slide that says how deep can we dig, if you click the present button and then click on this slide, it'll take you to a link to a YouTube video that's just kind of for fun, showing you that humans, when we're exploring the Earth, we really have only looked at just this tiny fraction in the crust, because we have not actually explored down into the mantle or the core of our Earth. So if you have questions, please make sure that you let me know. Make sure that you do today's assignment. You have 3 sentences that you need to write, and you want to get those completed as well. And as always, if you need help, please let me know.